For this one, it says a rectangle has a perimeter of 200 feet. What length and width should it have so that the area is a maximum? So we're going to go through this. We're going to draw a rectangle. We do not know the length or the width, but it does say it has a perimeter of 200 feet. Because it's a rectangle, aren't the opposite sides the same? So if the left is X, the right is X. If the bottom's Y, the top is Y. So when it says the perimeter is 200, perimeter means you add all the sides. So the perimeter is going to be X plus Y plus Y, but it says it's 200. So that means X plus Y plus Y equals 200. We're going to simplify this. So this is going to be 2X plus 2Y equals 200. What do you think I'm going to tell you to do with this 2x plus 2y equals 200? Divide by 2. So we're going to get x plus y equals 100. But because we have two different variables here, x and y, it's not just in terms of x. It's all x and y. I need another equation. Anytime there's two variables, we need two equations. So I use perimeter. Now I have to find something else. So it says, what length and width should it have so that the area is a maximum? So what does that tell us? Our second equation has to deal with area. So now area is equal to length times width. So based on our markings and our labeling in our diagram, wouldn't our area be x times y? But now I don't want y. I only want x. So I'm going to go back to the perimeter equation. And what am I going to do? Solve for y. So we're going to get y by itself. So I'm going to subtract the x. So y will equal 100 minus x. I don't want the y because our calculator has x, the button x. So it's just to keep it making more sense for you. So now we're going to have the area is equal to x. And now instead of y, what am I going to sub in? 100 minus x. And this is what we type into our calculator. So we go to our calculator. And I gave you the window. So I said, let's make our x minimum 0, our x maximum 200, our y minimum 0, and our y maximum 4,000. And now I'm going to go to y equals, and I'm going to type in our equation, which is x times, you need parentheses, 100 minus x. Graph. And there's our maximum. So they're saying what length and width should it have so the area is a maximum. So I'm going to go second trace, go to our maximum. I think my maximum is off. Good. So we get x is equal to 50. So our x dimension is 50. How do we find so that's our length. How do we find the width? So x is 50. How do I find y? Aaron?
Like x into y equals 10, not 100 times that.
You got it. So y will equal 100 minus 50. So y will equal 50. So this is actually a square. All right. Who wants more time to try the second one on their own? Raise your hand if you want more time. Try the second one and then we'll go over it. Okay, let's go over number 2. So it says a farmer needs to fence a rectangular pasture adjacent to a river. He needs 100,000 square feet in order to have enough grass for his herd. What dimension should be used that would require the least amount of fencing if no fencing is needed along the river? So this is one of the river problems. So here's our river. And then we're going to create a fence on the other 3 sides. So we know the sides that are across from each other are equal. So we have 2 x's and 1 y. So it says he needs 100,000 square feet in order to have enough grass for his herd. What does that 100,000 square feet represent, Luke?
You put like y, x, y instead of x, y.
So have those 2 be y and the other one be x? Sure, it's whatever you want it. It just might make it, no, actually, it wouldn't really be much different, the process. Be okay. Okay, so what is that 100,000 square feet in order to have enough grass for his herd be? It's the area. That's telling us this area is 100,000. So what does that mean? That means our area, which is length times width, so our area, which is x times y, but that has to be 100,000. So x times y equals 100,000. Because I have 2 different variables, what else do I need? Or what else do I create? Another equation, a different equations. So let's see what else they're telling us. So we use the area, the 100,000. It says what dimension should be used that would require the least amount of fencing? Well, the fencing, isn't it these 3 sides? These 3 sides are not the area. What are these 3 sides? The perimeter. So the 3 sides together are the perimeter. So the perimeter will be x plus y. So the perimeter will be 2x plus y, but I don't want it in terms of y. I don't want y's. I just want x's. So what should I do if I just want x's and I don't want any y's? Aaron?
Move the x over in the area.
Good. Go back to the area one and solve for y. So we're going to divide x on both sides. So that y will equal 100,000 over x. So now the perimeter in terms of x, so I call it P of x, will be 2x plus 100,000 over x. And this is what we're putting into our calculator. So it says we want to require the least amount of fencing. So should this be a minimum or a maximum? Minimum. All right, so we're going to go to our calculator. I gave you the window. So our window is 0 to 800. And our Y maximum is 4,000, same as last time, so we're good here. So we're gonna go to Y equals, and we want to type in 2x plus parentheses 100,000 divided by x. All right, and there's our minimum. So second trace and it's going to be decimals. So I said in the directions round 3 decimal places, right? So my 3 decimal places, I have 606. But can I leave it 606? No, you have to look at one beyond it. Since that's 5 or bigger, what do I do with that last 6? Make it a 7. So it's 223.607. So our x is equal to 223.607. And now to find the y, what you're going to do, give me 1 second. The y is going to be 100,000 divided by 223.607. So our y is going to be 447.213. Yes, Nico. Never mind? Okay. All right, number 3, guys.
No, I just wrote back sheet. Two lines. You isolate what? Right? This is
What happened?
you isolate y or x.
Do we x out the y or the x? We isolate the y so then we could plug in for x.
Yeah, I don't know
You always, it's easiest to leave it in terms of x to keep the final equation only having x's.
Yeah, that's what I did.
Do you want me to look at your work?
It's okay.
Sure. Did you understand how I did it?
No, yeah, I did the same thing except you know how there's like 2 sides, but then I put the y here, then the y's here, and you put the x's here, so you had 2x and I had 1x because I changed
Okay, but that's fine. So then your answers were switched, right?
I guess, yeah.
Yeah, so that's still good.
Okay,
So it's all going to be based on your diagram.
Oh, okay.
So that was based on my diagram. So you got the same 2 answers. They were just
Okay,
switched, right? Because I put my x here and my y here, so it shouldn't be the same.
Okay, that's fine.
Then you're done.
Wait, so what was this one? What the answer? Yeah, sure.
The answer for 2? These 2. So it says what dimensions. When they ask for dimensions, they want the length and the width. So guys, my advice for these, like I said, with the parabola problem or the shooting star problem, these distance ones, my advice is to make, when you plug into the distance formula, the point they give us, let's make that point x2, x1, y1. So make the point they give us x1, y1 when you're plugging into the distance. And same thing for the parabolas. Make the point I give you x1, y when you plug into the distance formula. I think we realized it's a lot more complicated when you plug it in as x2, y2 because then you're going to need more parentheses. So it's better just to have it be x1, y1. It will still work out.
Okay. Well, I did x2, y2 for this one, but I think I got the right answer.
It will still work out. It's not that it will be wrong. It just leaves more room for error when you're plugging into your calculator. Yeah. Yeah, so I just do negative root x. Parentheses then squared. Okay, I want to be able to go over the last problem also, so let's go through this one. So they're saying we have a shooting star, which looks something like this, and we want to know the point that's closest on the shooting star to, let's say this is 6, 0 right here. Right, so we're going to use the distance formula, where distance is equal to the root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Now we know a couple of things. We know we have the point 6, 0, which I said make this x1, y1. And we also know that y is equal to the root of x. So we'll keep that in mind. So now I'm going to plug into my distance formula. So d will equal x minus 6 quantity squared plus y minus 0 quantity squared. So remember, I told you to plug in x1, y1, or 6, 0 as x1, y1. The point I give you, make it x1, y1. It just makes it a little bit easier with the parentheses. So now we're going to not want this y. We want it all in terms of x. So that means we know y is equal to the root of x. So anytime I see a y, I'm now going to plug in root x. So here we have d of x will be x minus 6 quantity squared, perfect, because it's all in terms of x, plus, now instead of that y, I'm going to put the square root of x minus 0 quantity squared. So now d of x will equal x minus 6 squared plus root of x squared. Guys, but what's the square root of x squared? X. The square root of x squared is just x. So you can simplify this even more if you wanted to.
Yeah.
You don't have to. No, you could put it into your calculator just like that. But why add more parentheses if you don't have to? And this is what we're going to plug into our calculator. And when you plug into your calculator, I'm just going to tell you so we have time to do the last problem. X will equal 5.5. And then our y will equal the root of 5.5. Not 5 times 5, 5.5. So then y will equal 2.345. So our final point is 55, 2.345 is your answer for this. Yay.
So like, I know you said you want like the decimal spots, but like some of them you don't have to. Like.
Yeah, if you don't have to, then you don't have to. It's only when it's like a run-on decimal, then go to the 3. All right, the last one. Do I have time to do the last one? I think we have time to do it together. Okay, an open box is to be made from a rectangular piece of cardboard that is 8 by 5. So here's my cardboard. By cutting out congruent squares from each corner. Who remembers, what do I label these squares? X. Okay, so now I'm cutting out these squares. So when I cut out these squares, hey, our length is not going to be 5 anymore. What's it going to be? 5 minus 2x. And the bottom is no longer going to be 8. What's it going to be? 8 minus 2x. All right, find the maximum volume. So this time they want us to find the volume. Well, we know volume is going to be length times width times height. So our volume will be 5 minus 2x times 8 minus 2x, What is the height? X. If you fold it up, it will have a height of X. Is this all just one variable? Yes, since it's all just one variable, do I need to try to make another equation? No, I don't need another equation because this is all one variable. So this is what we're going to put in our calculator. And if you put this into your calculator, you're going to get X equals 1. So find the maximum. Oh, sorry, they want the maximum volume. So the max volume, who remembers in the calculator which one represents the max volume? The y in your calculator. So the y in your calculator is going to be 18. So it's 18 inches cubed is your max volume. But then it's also saying the size of the square. Well, isn't the square x by x? So our x was 1. So size of square will be a 1 by 1. So each square is a 1 by 1. All right, we're done with this review. Does anybody want to see me plug this into the calculator? Because we have a couple minutes where I could show you. I'll come show you on yours.